Okay, so welcome everybody to the video on solving rational equations. Just a really quick preview of what's going to be on this video. First off, we're going to figure out, okay, what's a rational equation? Um, in order to solve these things, we need to find what's called an LCD, lowest common denominator. So quick refresher on that. You should know that already, but it doesn't help to have a refresher. Um, doesn't help, doesn't hurt to have a refresher on it. Solving rational equations. We're going to start solving them. This will be the example on the PowerPoint. And then solving rational equations, we'll have 4 different examples on that. So a total of 5 different examples on this thing. Um, I'm going to post this on YouTube. So part of the reason why we're going over this kind of preview is so that you can just look down at the description part and skip around to any part of the video that you want, just depending on which part that you need a little bit of a refresher on. Okay. So yeah, feel free to jump around on the description part of the video. All right. So solving rational equations. Basically, we're going to have a rational equation. We're going to solve it. Solving means that you get x by itself. We're going to figure out what x value will make these two expressions equal to each other. So what is a rational equation? Rational equations are basically an equation that contains at least one rational expression. So there's all kinds of ways that these things could look. That's part of the reason why we have so many examples. And my examples will not be extensive, but I'm going to show you different methods that should work for just about any rational equation that we throw at you, or at least at this level in Algebra 2. So yeah, you have a rational expression equal to another rational expression, and we're going to solve these things. So a couple steps here. Here's the method that I'm going to show you. There's definitely more methods out there, but this is the one that'll be on this video. So first off, you're going to factor all denominators. Now it's important to note that this is a little different than what we've been doing when we've been simplifying, because so far up till now, we've been factoring the numerators and the denominators. Now we're just going to be factoring the denominators. So you don't necessarily have to worry about the numerators until you start solving. All right. Once you got the denominators factored, if you remember in past videos, we learned that that's probably the best time to figure out what the restrictions are on your x values, because we want to know what x values are not allowed to be there. Those are your restrictions because they would make your denominators 0. Once we find the restrictions and it's all factored out, we're going to build our LCD and then multiply both sides of the equation by that LCD. This is essentially what's called clearing the denominators, so you don't have to work with fractions anymore. This works with linear equations as well. It's a common method, but we're going to still use it in these equations. And then we'll have an equation left over that's not rational anymore. Basically, your denominators will be gone, and you just use whatever solving techniques we've used in the past. If it's a linear equation, you just solve it like any linear equation. If it's quadratic, you have a couple choices there, or a few choices: quadratic formula, factoring, completing the square, all those good things that we did in previous chapter. You'll have all kinds of choices. Now, once you get your answer, you need to double check that answer either by plugging it in and making sure it works, or that's why we did this second step right here. If your answer is one of these restrictions that we find that makes your denominator 0, you don't even got to plug it in. You can just say, oh, wait, that's not an actual answer. So that's called an extraneous solution, meaning it doesn't actually work. The equation to begin with, maybe it had something that you did on both sides that wasn't necessarily something you should have done with certain x values. So just double check this last step against your restrictions that we found in step 2. Or if you don't want to do step 2, you actually don't have to do step 2, and you can just plug these directly in. But I think it's easier for just finding restrictions. All right, so uh, first thing we're going to do, since this is one of the steps, is finding the LCD. We should practice this just to make sure that everybody's up to par on that. Now, a quick refresher on LCD. You have done this in the past with just regular old fractions. Now, lowest common denominators, that's basically figuring out, okay, what number can a 4, a 6, and an 8? What can we skip count each one of these, and what's the first number that pops up on each of them? So skip counting like by 4s, 4, 8, 12, 16, 24, 6, 12, 18, 24, 8, 16, 24. So they each hit that number 24 is a common number. So we can kind of do that with these. You can't really do that with polynomials, though. I've never heard of skip counting polynomials. It might be out there and just something I don't know about. but I'm thinking it doesn't exist. So I'm going to show you another method, but I'm going to show you with these simple fractions. That way you can kind of see how it works. So just like we're going to do with rational expressions, we're going to factor all the denominators. In this case, we're prime factoring. And then we're going to take factors from each of these to build basically the smallest, use smallest in a kind of liberal way, but the smallest possible denominator. So the way to do that, you're just going to take pieces from each. So right now I don't have one, so I got to start somewhere. So I'll go ahead and start with this one. I'm going to take this entire factor denominator and just throw it onto my LCD. So far, this 1/4 gave me a 2 and a 2. Now what I'm going to do is I'm going to piece together my LCD from other pieces of my other denominators. So this denominator has a 2 and a 3. I have two 2's already. I just want to add on the new pieces. So this has 1, 2. I already have 2 of those. So I don't need this 2 because I kind of have an overkill on 2's for this. So I don't need an extra 2. I only have 1 here. I already have 2. So all I need here is a 3 because I don't have a 3 yet. So you're just adding the new pieces on. So the 3 comes on. Now this one has 3 2's. I only have 2 2's. Now, the number of 2's does matter. So if I have 3 here, I don't have enough here. I need a third one. So I got 2 from here already, but I just need a third 2 because it has to have new pieces here like that this 8 can become. So I have 2 2's. I already have 2 2's. I need a third 2, so I'm just going to pull off with another 2 there. And that's it. So you just pull the new pieces from each of the other denominators. And then now I got 24. Okay. So that's that step. I just wanted to make sure that you saw that. So again, these are our steps. So let's see what this looks like with an actual example. So I noticed this after I made it. This one is a pretty simple one actually in building your LCD, but let's go ahead and do this. So factor all denominators. So I have my x minus 2. So what I'm going to do is I'm going to take those two, um, and factor them, but there's not really much to their factorization. That's why I said this is kind of an easy step. X minus 2, it's not a trinomial. There's no GCF that comes out. It's not a difference of squares, so it's just x minus 2. So whatever it doesn't factor, if it's a binomial, go ahead and put in parentheses. X minus 2 just stays x minus 2. So if I was going to find my restrictions next, basically that's what would make these 0 once they're factored out. So a 2 would make 2 minus 2 would be 0. Same thing over here, 2 minus 2, so x cannot be 2. So I got to keep an eye on that because if my answer at the very end is 2, I already just said that I can't have a 2. X cannot be 2. So that's why we need that step. Okay, now we're going to multiply both sides by the LCD. This one's already done. I'm going to go ahead and kind of show this. So a little side work here. So I'm going to take my first denominator, x minus 2, and then I look at my next denominator. Is there any other factors here that I can add on to this? Like if it said x minus 2 times x plus 5, I would put an x plus 5 onto here. But it's just another x minus 2. So I already have that. So actually x minus 2 is already your denominator, your common denominator. So this one, that's why I said it was kind of simple. We didn't have to really build much. Now we're going to multiply both sides by that LCD. So the way this will look is I have my 5 over x minus 2 and 3x plus 4 over x minus 2. I'm going to go ahead and just multiply both sides by x minus 2. So I took my LCD, and I'm just multiplying both sides by that LCD. Okay, so I did it to the left. What I do to the left, I have to do to the right for multiplication. Now what you'll see is when I multiply by x minus 2 and I divide by x minus 2, it's basically like having this on top and this one on bottom. So those two are gone. Same thing here. I got these two matching up. So those two are gone. And there you go. That's how you clear your denominators. Now, once the denominators are cleared, you're just left with the numerator. If on this step you have denominators still, you did something wrong. You missed something, you didn't cancel something, you didn't build your LCD right, something didn't go right. Your entire bottom parts should be gone. And then whatever is left over on top, you should multiply together. Now, there's nothing left on top, so it's just a 5x. There's nothing here. There's a 3x plus 4. Sometimes you'll have something left that didn't cancel. You need to make sure to multiply those together. But in this case, there you go. And just solve that equation. That's a pretty simple solving. Subtract 3x from both sides, then you divide by 2, x equals 2. Do not box that yet because you need to double check this answer against your restrictions that we found. So that's the last step. I got x equals 2. I found out, whoops, x cannot be 2. So this is a extraneous solution. Do not box it because it's not the actual answer. In this case, this has no answers. Sometimes when you're solving this, you'll have a quadratic. You'll get two answers. One of them won't work, and the other one will. Sometimes they both might work. You just got to make sure you double check with your restrictions and then take those off of your answer. Okay. So there's no solution in this case. Sometimes there will be a solution even if one of your answers gets knocked off by those restrictions. Alrighty. So what we're going to do now is some examples on the dot cam. If I could pull the dot cam up. All right, so here we go. First step is to factor all your denominators. So this denominator is just an x, so that one just stays an x. I'm going to cross off this once I factor it. That way I can kind of see that it's done. Okay, x squared, that's another monomial. Sorry about that. So that's just going to be x times x. And then this last one, I'll do in green, is just an x. All right, so now what I'm going to do, everything's factored on the denominators. Like I said, cross those off because this is basically the same thing, just factored. So I don't have to rewrite the entire step. I just know this turned into that, that turned into that, that turned into that. So I'm going to show a lot of my work just on this part, just to save a little bit of space here. So my LCD, lowest common denominator, I'm going to start with this one. So it's just x. Okay. Then this one, I already have an x. So I don't need this one, but this one has two x's. So I only have one so far in here. So I need an extra x added on here. Okay. And then here I only have one x, but I already have an abundance of x's. Now if there's three x's, I'd have to do an extra x because they'd have to pull an extra one. So my LCD is just x and x. All right. So now we're going to find our restrictions. So if I look at all three of these, I can see my restriction. Okay. What would make this 0? It's just an x, so the only thing can make that 0 is a 0. So x cannot be 0. So if I solve this out and I get 0, that means something went wrong. Or not something went wrong, but basically I would cancel off that answer. So this one has an x and an x. So I already have that. X cannot be 0, and then x cannot be 0 again. X can't be 0, so x cannot be 0 is my restriction. All right. Now, what I'm going to do here is I'm going to multiply all of my numerators by this LCD. Now, the way I'm going to write this is I'm just going to write it right on top. So x times x, x times x, x times x. So just across the entire top, all the numerators is being multiplied by x's. Now I can do my cancellation step because I have an x on the bottom and an x on the top. Those are gone. I have two x's up here. I have two x's down here. Those are gone. And x and an x, those are gone. All right. And what I did there was essentially I cleared the denominators. Now I'm going to look at my leftovers. I have my denominators all got crossed off, so those are gone. My new equation that I will be solving is going to be just my numerator part. So that says 2 times x. So I have a 2 times an x equals, and then this is gone, so I just have a 1, and then plus 4 times x. All right. And now I just solve this. So it's a 2x equals 1 plus 4x. I'm going to go ahead and subtract 2x. So 2x minus 2x is 0 equals 1 plus 2x. Subtract 1. So negative 1 equals 2x. Divide both sides by 2. X equals. So divide by 2, I got negative 1/2. All right, that does not conflict with my restriction. So that is your answer. Okay, so that's the first example. Let's do another one. second example. Let's see what it looks like when it's a little more complicated. So we have this one right here. So first step again is to factor all your denominators. So this denominator is a 2 times an x. This denominator over here, I don't really need different colors. This number here is just a 2. This one is just an x. Those don't really, ouch, I just hit myself in the head. Those don't really factor. So I got LCD. I'm going to pull this first one, 2 times x. Pull from this one. I have a 2 there, and I already have my 2 here, so that factor is not needed. I have an x here. I already have an x, so my LCD is just a 2x. Okay, so here's what I'm going to do. I'm going to next find my restrictions. So let's put a little res restriction. So x cannot be, and then figure out what would make this 0. 2 times 0 would make that 0, so x can't be a 0. That's just a 2. I can't really make that a 0, it's just a 2. So x can't be 0 again. All right, so what we're going to do here is, now step am I on? I found my restrictions. Now let's go ahead and go to multiplying each side by the LCD. Okay, so I got my 2x. I'm going to go ahead and multiply the top up here by a 2x, multiply this top up here by a 2x, multiply the top up here by a 2x. So I just took my LCD, multiplying it across every numerator that's there. All right, now I can go ahead and start crossing off. 2x on bottom, 2x on top. Oh wait, whoops, sorry. So this is why I like to cross those off, because then I might see too much stuff going on. This one became that, that became that, that became that. Well, that was already that, but anyways, so we got 2x and a 2x. Those are now gone. This was 2 times x. So my 2's are now off of there, and then my x's are now gone as well. All right. So this first one, I got x squared plus 2x minus 3. So x squared plus 2x minus your 3. Minus, because there's a minus sign, and then I got my x times x minus 3. It's this x times this whole thing. Be careful, don't just do x squared minus 3x and put a minus out front, because this negative's out front of this whole thing. So I'm going to go and tag that onto this x, which is here, and then distribute. Well, I will distribute in a second. So equals 1 times 2 is just a 2. All right. And now you have your equation that you need to solve. So let's go ahead and solve it. First step, go ahead and distribute that. So you got your x squared plus your 2x minus your 3. Negative x times an x is a negative x squared. Negative x times a negative 3 is a positive 3x equals 2. Combine like terms. I got an x squared and a negative x squared. When you combine those are gone. 2x plus a 3x is going to be a 5x. So 2x and 3x, that made that 5x. And then you got your minus 3 equals 2. All right. Now you have a basic kind of equation here that we're going to do. So you're going to add 3 to both sides. So you're going to get 5x equals 5. Divide by 5, so x equals 1. All right, so now what we're going to do is check that against the restriction that we found up here. So your x cannot be 0. It's not a 0, so we are good to go. Just box that guy, and you are done with that one. Okay, so next one. Let's go ahead and do this one right here. So for this one, you have a little bit more complex factoring going on here. Just looking at this one, I'm going to do my easy ones first for the LCD piece, or for the factoring piece, sorry. So my first step, factor all denominators. So I'm going to go ahead and factor this first part right here. X minus 1 factored is just going to be an x minus 1 again. X minus 1 factored is just going to be an x minus 1 again. Okay. So I still got to factor this one. Let me go ahead and do this in another color so it doesn't get mixed up over there. We got a trinomial. So we learned this little graphic organizer. So there's a 1 in front here. 1 times -4 is a -4. Bring down your 3. So two numbers that multiply to be a -4 but add up to be a 3 are going to be, so you got a 4 and a 1 would make a 3. So 4 minus 1, but which one is negative? Must be the 1. 4 minus 1 is 3. 4 times -1 is a -4. And keep in mind, since this is a 1 up front, we can go ahead and use a little shortcut here. So I got x plus 4, x minus 1. I don't got to do any of that factor by grouping stuff. Okay. I'm going to go ahead and cross these off. That way I don't confuse them again, because they've now become those factors. All right, so let's do the restrictions. Okay, restrictions are x cannot be. So what would make this a 0? A -4. Can't be a +1 either. +1 will turn those into zeros, which we do not want. So at the very end, just make sure to check your answer against that. Let's go ahead and multiply all my numerators by these. Oh wait, I didn't find my LCD yet. Oops. So let's find our LCD. From this first group, you got your x plus 4. You got your x minus 1. Okay. Let's see if we can bring anything new from these other two. So from this one, nothing really new that I can bring onto here because I already have my x minus 1. Same deal with this one. I already have my x minus 1, so I'm going to multiply all my tops by x plus 4, x minus 1. Plus 4, x minus 1, x plus 4, x minus 1, x plus 4, x minus 1. Okay, so I took the LCD, multiplied all my numerators by it. Let's go ahead and clear our denominators. What color have I not used? I used all my colors. I only got 4. Oh well. Okay. So, my numerator here, I have matching my denominators, so those are gone. I just have my 1. This one has an x minus 1, x minus 1, x minus 1, x minus 1. All right, so let's see what's left up here. I got a 1 times, basically those are all gone, so I got a 1 plus, I got a 1 and an x plus 4. So I would say 1 times x plus 4. And then I got a 4 and an x plus 4 left over here. And there you go. You have your equation with no denominators. Now you would solve this. This was way back in first semester, so you should be pretty proficient at distributing. So I got 1 plus 1 times x is x, 1 times 4 is 4, equals 4x plus 16. Combine like terms, x plus 5 equals 4x plus 16. Okay, I subtract x, so I get 5 equals 3x plus 16. Subtract 16, so I get -11 equals 3x. Divide by 3. Whoops, there you go. So I get x equals -11 thirds. That is not one of my restrictions. And there you go. Okay. Like I said, this has quite a few examples. I got one more left for you. And you can, like I said, you can skip around on the little description part of this page, this video, and you don't have to watch all these, but it does help. All right, factoring all denominators. This one I noticed something though. If you notice, this 1 doesn't have a denominator. You can give it one if you want to. Don't really have to, but you can. So I'm going to factor each one of these. This first one, x squared minus 1, that's a difference of squares. So this just quick factorization, x plus 1, x minus 1. That's why I said that those shortcuts are pretty helpful. Okay, so this next one, we got our x plus 1. That one just factors into an x plus 1. And our last denominator, which we didn't necessarily have to do because it's just a 1, is just a 1. Okay. Next part, let's figure out our restrictions. So restrictions, x cannot be. So a -1 here will mess it up. A +1 here will mess it up. That's still a -1, and this one's just a 1, so there's no way to turn that into 0. So I just don't want a -1 and a +1 for my answer. If I get those, then basically make sure you don't box them. All right, LCD time. CD. So I got my first one, x plus 1, x minus 1. Okay, that one's done. Let me cross these off real quick. Can I add anything new from here? No. Now, I don't think I did any examples where you could add stuff. But if you could, let's say that you were able to, I don't know, factor out an x minus 5. You would put an extra x minus 5 since it's not on here. Okay. But I couldn't, so because I already got x plus 1 right there. 1 doesn't really matter because if I put times 1, I mean, you multiply by 1, it doesn't really do anything. So I don't really got to worry about just a plain old 1 there. All right, so I got my LCD. Let's go ahead and multiply all my numerators by that. So I'm going to multiply everything by x plus 1, x minus 1. So x plus 1, x minus 1, x plus 1, x minus 1, and x plus 1, x minus 1. All right, and let's cancel stuff, or quote unquote cancel. So I got my numerator up here has these two factors. I got the same thing in my bottom, so those are gone. X plus 1 will come off with this x plus 1, and that's just a plain old 1. I don't have any 1s up here. This 1 is part of the group. Please do not cancel this 1 with this 1. That just works with multiplication. So yeah, don't do that. Alrighty, so my leftovers, I have a 4, so I got a 4. I got those cancel off, so I got equals 1 times x minus 1. And then I got plus 1 times these two, but keep in mind 1 times anything is the same thing. I didn't even have to necessarily write the 1 right there either. But I got my x plus 1 and x minus 1. All right. So for this part, we are gonna, well, we're already done getting rid of the denominators, so now this is just solving from here, solving equations that we're more familiar with. So I'm going to distribute there. Move this up. So I got x, 1 times -1 is a -1, plus, and then go ahead and multiply this thing out however you remember. Now, if you remember, this was actually the same thing as over here, already factored out. So we should get an x squared minus 1. So I'm going to distribute this x into there. So x times x is x squared minus x. Same thing here. Distribute. You get a plus x and a minus 1. And now we're just going to start combining like terms. So I can see that these x's are going to go away. Let's bring down the 4. Start with your x squared. Just stays x squared. Those x's were gone, so I just got my plus x and minus 2. Okay. So this is a quadratic, so you can solve this any number of ways, but I got to get one side equal to 0 before I start solving quadratics. So that's 0 equals x squared plus x minus 6. All right, so from here, you can either do quadratic formula, you can do completing the square if you wanted to. I'm going to factor, or try to factor, see if it factors. So there's a 1 out front, so I got a -6 and 1. So if I can find two numbers that multiply to be -6 and add to be 1, then I know that this is factorable. 3 and 2. 3 plus 2 is a 5, but 3 minus 2 is a 1. So I know I can make that 1. I got to make a negative. 3 times negative 2 is negative 6. There you go. So 0 equals. Now, since I have a 1 out front, I don't have to do the factor by grouping stuff that I usually do. If you want to, you can. Just kind of takes up some extra time though. So I got an x plus 3, and I have an x minus 2. All right, and then now I just split this to two equations. This is all stuff from our factoring unit. So x plus 3 equals 0, and x minus 2 equals 0. Really simple equations there. So x equals negative 3, x equals 2. Okay, last part, double check these answers with your restrictions. My restriction said I could not have a negative 1 or a 1. I don't have a negative 1 or a 1, so both of these are your answers. And that is it for the examples. Pretty long video, but like I said, a lot of ways to skip through this thing. I just wanted to give you as many examples as I could. I mean, I could definitely give you more, but that's all I want to give for now. All right, if you have any questions, feel free to stop by during my tutorial time, and I'll see you there. Okay, bye-bye.